Hey there, Joel here, and welcome to this online class. Today we're going to learn a new chapter, and that is chapter number 2. Is matter around us pure? And I'm sure you have watched chapter number 1, which was talking about matter in our surroundings. Ignore the sound. Okay, so in case you haven't watched it, then to understand this chapter, is matter pure, you have to watch that video. So I will link that video in the description box. Go ahead, watch that, and let us start with this chapter, is matter around us pure? So to understand this, we need to know how do we actually look at matter in a way. Is it its physical state, or are we talking about its chemical composition? So whenever we look at anything, for example, this charging brick, right? Now this is a solid. So when I say it is a solid, I'm looking at it in the perspective of physical state. But whenever I'm talking about some of the components or particles inside it, how is it made up of microscopically, what is it, then we are talking about its chemical composition. Now based on the chemical composition, a particle or a matter can be subdivided as a pure substance or mixtures. Let me give you an example of a pure substance. So if I have a gold chain, the chain is made up of gold. It's a pure substance. There is nothing else in it. But if that gold chain was not pure, and you have bought it from a fair where it is just iron or metal and coated with gold. So here there are two substances involved in it. So when I'm talking about pure substance, from the surface till inside, it is entirely made up of one kind of matter. So when you're looking at matter and its chemical composition, we are looking at those perspectives. What is it actually made up of? But in a physical state, we just look at it as, is it solid, liquid, or gas? That's it. So under this has to be over here. So under pure substance, it can be either classified as elements or compounds, and under mixtures, it is classified as homogeneous mixtures and heterogeneous mixtures. Each and every terminology and the understanding of it we are going to study in this chapter only. So right now, just have an overview of what are we actually learning in this chapter. We are going to look at matter and its physical state and chemical composition. Most of the physical state part which is there is already dealt in chapter number 1, that is matter in our surroundings. Today, or in this chapter, we are looking at it in terms of chemical composition. So more of the interior part, or how is it actually made up of. So I have two beakers, one over here, and it is made up of some particles, right? Okay, I'm going at a microscopic level, so you can see each and every tiny particle. Now these are not fine marbles that are put all red color marbles together, but they are tiny particles. So you are zoomed it too much and you are able to see the tiny particles over there. Okay, same way I have another beaker which is another set of particles. So if I say these ones are red color particles, which you can see are the spicy ones, okay, and the yellow ones are the sweet ones. So one beaker is made up of two types of particles, the other is only one type, okay, which brings us to the first understanding of a pure substance and a mixture. Okay, so I told you a pure substance is made up of one type of matter, the other is made up of different kinds. So let us understand by word definition what to be made by a pure substance. A pure substance consists of a single type of a substance. Looking at the picture, you can understand, I'm sure about that. When we talk about a mixture, mixture consists of two or more pure substances. So here I have two pure substances which is making up the mixture. I can have more than that, but two or more. Next point is pure substances cannot be separated into other substances by physical methods. Now, what do we mean by physical methods? Hand picking is one kind of a physical separation method. So straight away, can I, if I have that chain, remember that, right? The gold chain which is pure, can I separate it? No. Even if I break it into half, that half of the chain will be of gold, the other half will be again of gold. I can't separate it by any physical method. Mixtures can be separated into components by physical methods. Imagine, that chura that you get, which you normally eat as a snack in the evening. It has, some ground nuts, or it might have some cashew nuts in it. Then it will have some shoe. All of it is together is a mixture. Just an example, okay? Don't give chura as an example for exam. This is just for you to understand better what do we mean by a mixture. So I can remove all the ground nuts by hand picking, right? So there's a physical method that I'm using to separate one kind of a substance. Similarly, I can remove all the shoe, I can remove all the cashew nut seeds. So that is separation, okay? So mixture can be separated. Pure substance cannot be separated with a physical method. Pure substance has its own definite properties. Now, whatever are the properties of the gold, those are the properties of that chain, right? Whereas in mixture, it will have properties of the substance that are there. For example, if you eat the chura, that the sweetness might be because of some sugar sprinkled on it, or that spiciness, the chaat flavor, maybe because of the show. So you get that entire flavor is because of each and every substance. Next part, okay, again two beakers and both of them are mixtures, right? So why am I saying that they are the mixtures? Because both of them have different or two kind of components involved in it, right? The entire substance or the matter is made up of two different substances, red and yellow. But the way that is mixed together is different, right? Here if you look at, I'll just try to zoom in into 9 particles over here, this part. Now these particles, some of them are red, some of them are yellow. Similarly, if I consider the same portion somewhere else, I'm not having the same amount of red and yellow particles in there, right? Same way if I look at the other one, I have 8 red color particles, 1 yellow color particle. Same way somewhere else, red color particles, 1 yellow color particles. Okay, now a mixture with non-uniform composition of particles. That means the particles that we are considering are not uniform. Uniform means they're not same. In one place it is more, the other place it is less. Whenever such thing happens, okay, those will be called as heterogeneous mixtures. So we studied or we understood what is a pure substance, what is a mixture, and now we are further understanding a different kind of mixtures. The one is a heterogeneous mixture where the substances particles are not uniform, it is heterogeneous. Where it is same, it is called as homogeneous. So homogeneous mixture are nothing but mixture of uniform composition of particles. It is same. Okay, if it is different, it is heterogeneous. If it is same, it is homogeneous mixtures. Okay, so let us take a few examples. I have sugar plus water, salt plus sand, salt plus water, and some properties. Okay, so let us understand heterogeneous mixtures and homogeneous mixtures. So salt or sugar plus water is a homogeneous mixture. Why? Because if you take sugar and mix it in water, and maybe you take a straw and dip it straight to the end of the glass and you sip it, you will get that sweetness in the water. Same way, if you taste the surface, you will get the same taste, right? So it's a homogeneous mixture. The particles that are there on the surface and the deepest part of the glass are same. Salt plus sand, if you mix them together, definitely they will be heterogeneous mixtures, because they are not going to be uniform throughout the container. Salt plus water will again become homogeneous, because the water at the surface and below will be same salty water, same taste. Heterogeneous mixtures are visible with a naked eye. Okay, so you can see that there are two different particles. They can be separated by filtration. So especially particles which you can see with your eyes, okay, they can be separated by filtration. Mixture is stable. Now here, homogeneous mixtures, they are stable. Now what do we mean by this? If I take sugar and salt and sugar and water and mix it together and keep it like that for a day, that sweetness in that sugar will remain the same the next day also. Okay, that's the reason we are saying it is stable. Particles are not visible with our naked eye. So once you mix that sugar and water together, I can't see any sugar particles. They have already dissolved in the water. Again, if you are not able to understand, then please go and watch the first chapter, that is Matter in Our Surroundings, to understand all these things in a better way. Sulfur plus iron filings again is a heterogeneous mixture. I just put them together. Sulfur is a powder, iron filings are crystals, kind of material, not exactly crystals but filings, right? So you put them together, I can see them with my eye, they are visible, so they become a heterogeneous mixture. Next, so let us understand a little bit more about sugar and water. When you mix, it becomes a solution. Okay, sugar plus water, you mix them together, you get sugar solution, right? So here it is a homogeneous mixture. I've already discussed what is the meaning of homogeneous mixture. Next, particles can't be seen by a naked eye. You cannot see them. Once you have mixed, they have dissolved. Okay, particles cannot be separated by filtration. So something that is already dissolved completely into that solvent, you can't separate it by filtration. Solute particles do not settle down. So if they have mixed, we said that it is stable, right? So they mix thoroughly into that liquid. So that's how particles do not settle down. If imagine this, I take water and I put sand inside it and then stir it. After a while that sand will start settling down, correct? Because it is not getting completely dissolved in it. So solute particles do not settle down when you are talking about sugar and water. Particles do not scatter a beam of light. What do we mean by this? They do not scatter. So if I take maybe a torch and put show light on that glass, then they won't scatter the beam of light. More in depth we are going to study in this video only. Okay, so give me some time. Next, let us take an example of chalk plus water. Chalk is nothing but your normal writing board chalk. I'm taking that and mixing it in water. So those kind of substances are called as suspensions. Now why suspension? Let us understand. They are heterogeneous mixtures. Okay. Particles can be seen with a naked eye. The moment you put chalk powder in water, I can see that there is chalk powder. Chalk powder, chalk powder, chalk powder. I can see that, right? Particles can be separated by filtration. So something that you can see with your eye should be able to be separated by using the method of filtration. Particles settle down. So the particle of chalk that you can see can settle down in that liquid. Okay, in this case it is water. Particles scatter a beam of light. Again, we're going to understand this in this video. Okay, so I hope you are able to understand what do we mean by a solution, what do we mean by a suspension. So when particles completely dissolve, it becomes a solution. When particles don't dissolve, it becomes a suspension. You can be asked a difference between a solution and a suspension for exam. That's the reason, I'm trying to put up a little sentences, otherwise I would just write words. For those students who find it difficult, to make notes for them. So please make your own notes as you're watching the video. Please don't watch it like a movie, because it is not a movie. Okay, and if it was, then I would be a bad actor. I can't act. So please make your own notes, write them down on your book. Whatever you can understand in your own words, ask yourself, this part of that slide that I can see a video, what do I understand? Make your own notes, and that's when you will be able to know and tell yourself, yes, I understood this chapter, or you didn't understand this chapter. Okay, let us continue. Next, I'm adding milk and water. So when you add milk and water, it becomes a colloid. So let us understand the properties of a colloid. Now here, it is a heterogeneous mixture. Again, I have explained what is heterogeneous mixture in the previous part. If you still didn't understand, go a little bit, rewind the video and then check it out. Particles cannot be seen by naked eye. So when you mix milk and water, I can't see any particle. I can see it all white colorish liquid, but I can't see any particle of milk. Okay. Particles cannot be separated by filtration. So since I cannot see the particles, I can't filter it. Particles do not settle down in the solution. So when you put particle or milk in the water, normally what happens, see, if I put sand and water, I can see the particles, and if I stir it, after a while the particles would settle down. That's when you call it as a suspension. Now here it is called as a colloid because particles you cannot see, but particles are not completely settling down as well. So some properties of a solution, some properties of a suspension together will give you a different kind of a solution, that is a colloid. So you have nothing but a solution, suspension and a colloid. Next, particles scatter a beam of light. Next part we are going to understand what do we mean by this. Okay, so here I have a glass of water and say I have added that milk particle. Now they had to be white, but can't help it, right? So you have to see them. Okay, and then I get a torch and then I put it on, and then the rays will pass through that entire glass, right? And that's when I will be able to see, okay, the glow in that entire glass. So you can even try it at home. Take a glass, drop a little bit of milk inside it, and then put a torch, and then you will be able to see the entire milk kind of glowing. Whereas if you do it with sugar water, you won't be able to see it, nor with sand and water. So When a beam of light is passed through a colloidal solution, we have already understood what is the meaning of colloidal solution. The colloid particles, those are nothing but the milk particles, okay, scatter the beam of light. Scatter means to give it more, okay, to spread it across. Scatter the beam of light, and the path of light becomes visible in the solution. So you can see the path of light properly. That is called as Tyndall effect. Okay, so scattering of beam of light is nothing but you have a colloidal solution, you pass light through it, and I can see the scattering of light. The beam becomes visible inside the solution, not everywhere. Okay, is called as Tyndall effect. Okay, some of the points that you have to remember: when light enters a room through a small hole, some of you all might have a roof of tiles, and then if there was a slight gap, then you can see that entire beam, right, entering, and then you can see all those particles moving everywhere. Tyndall effect. Okay, scattering of light by water droplets in the mist. So say this kind of an example also you will be able to see in nature, right? Sometimes you must have noticed, certain pictures or experienced it in a forest or early in the morning. If you just go in for a walk, you can see the rays of light, the sun rays are nicely passing through those trees. Tyndall effect. I hope whatever I've explained is clear till now, and if you did understand, then please don't forget to hit that like button, share this video with your friends, and subscribe to the channel. Till then, take care and bye bye.